Hi everyone, in this video we are going to discuss about theorem number 23 from the geometry of circles. The theorem says angle between two secant lines intersecting outside of the circle, the angle APC will be equal to half times the central angle subtended by the arc BD minus the central angle subtended by the arc AC. As you can see in the diagram, we have a circle with the center at the point O, and I have two intersecting secant lines. I have named them as L sub 1 and L sub 2. The two secant lines, they intersect each other at point P, which is outside of the circle. The first secant line intersects the circle at points A and B, and the second secant line intersects the circle at points C and D. The central angle subtended by the arc BD is going to look like this. It will be the angle BOD, and similarly the central angle subtended by the arc AC is going to look like this. It will be the angle AOC. Whenever I say an angle, please assume that I am talking about the measure of the angle, the degree measure or the radian measure of the angle. In order to do the proof, I have to do just one little construction here. I am going to join the points A and D. Now let's look at the triangle ADP. In this triangle, what would be the angle ADP? Well, that is actually an inscribed angle for the arc AC. From a previous theorem, we know that the size of an inscribed angle is equal to half of the size of the central angle. So in this case, we can say that angle ADP will be equal to half times the central angle, which is angle AOC, and that can be noted as half times AC with the arc symbol on top of it, which essentially denotes the measure of the central angle subtended by the arc AC. And similarly, what would be the angle BAD? Well, that is an inscribed angle for the arc BD, and its size obviously will be half of the central angle subtended by the arc BD. Now if you think about the angle BAD with respect to the triangle ADP, you will realize that angle BAD is essentially an exterior angle of the triangle ADP. So angle BAD will be equal to the sum of the two farthest interior angle of the triangle ADP. And from here we can say that angle APD, which is also same as the angle APC, according to the theorem we have to find the value of the angle APC, but here I have noted APD because we are talking about the triangle ADP. So I have noted it as angle APD. So angle APD will be equal to angle BAD minus angle ADP. Now let's substitute the values of those two angles there. So that's going to look like half times BD with the arc symbol minus half times AC with the arc symbol. And then if we combine them together, we can say that angle APD will be equal to half times BD minus AC with the arc symbol, of course. They denote the measure of the central angle subtended by each of the corresponding arcs. And this is exactly what we needed to prove for this theorem. So in a problem, if we are provided with the measure of the central angles of the two different arcs, then we can easily calculate the angle between the secant lines. I hope everything made sense. Thank you for watching. See you in the next video.